Alright, starting off with question 37, which we should have done yesterday, but we didn't because I don't know what I'm doing. Alright, so it is, what is the measure of angle D? And we're given this picture here. Now these little markings that we've got right here, here, and here, tell us that this triangle, A, B to C, is going to be an equilateral triangle. So we know that this angle, and this angle must be the same, and we've already talked about this. This means they're all 60. All three have to be 60, so that's 60, 60, 60, all add up to make 180. And then remember, we're looking for this one here. We're trying to find angle D. Well, if I can find one of these angles here, it kind of helps because we know that angle B and angle D must be the same. Now, why do I know that? If I break this off a little bit so it's easier to see, we've got this marking here that goes here, and this marking here that goes here. So we can see that this is an isosceles triangle because we've got one side and one side equal to each other. So that means that this angle down here and this angle here must be equal to each other. So if we can find this angle here or this angle here, we then have our answer. But we know right here that we have a straight line. So that's 180 degrees. And we know this side's 60, so we have to make that all add up to 180. So we'll take 180, subtract 60, and get 120. So that means this angle here is 120. Well, that means that B and D, whatever they are, they're the same thing, x and x. So 2x's plus that 120 equals an entire triangle, and we know that's 180. So that means 2x equals 60. So a single x equals 30. And 30 happens to be answer choice A. Alright, so this one is number 38. And 38 says, quadrilateral ABCD has vertices at A 26, B 42, C 64, and D 56. So that is this quadrilateral up here in the top right. And these x and y coordinates of each of these points are multiplied by negative 1.5 to create a similar quadrilateral in quadrant 3. Which similarity statement best describes the relationship between the two figures? So it's saying, basically, we want to set up a similarity statement, just like a congruent statement, stating which letters correspond with each other. So I'm going to start up here. I'm going to write this as A, B, C, and D is similar. So A, B, C, and D is similar to this figure in some way. Here's the important part of that. It would kind of make sense that since A is in the top left, T is in the top left, we should put them together. But what's important is because we multiply by a negative 5, it's taking this equation here and it's reflecting it over this line, because now that this was really positive this direction, now it's kind of positive this direction. So it's not quite that far away from that line, so now it's not quite that far away either here. So we can see that A and M correspond to each other. And because, again, when I multiply by a negative, this B was coming down here, it's reflected over this spot. By multiplying by that negative, we reflected it. So now the G corresponds to B. And next we're going over to C. Well, C goes up here to R. And last we come up this short side to T. So the key here was because we used a negative, it's no longer just lined up perfectly. The whole thing got flipped upside down when it came down here. So ABCD is congruent to MGRT. That looks like it's answer choice A. And that is the end of that problem. Alright, on to 39. 39 says, in geometry class, students are using parallelograms that have had the have been cut out of construction paper. Using one of these paper shapes, a student tears two consecutive corners from a parallelogram. Which best describes the relationship between the two corners that have been removed from the parallelogram? So you can see in my picture I've got some really ugly squiggles there, but those are the corners that have been torn out. And down at the bottom they have 4 answer choices. The first one says, the angles would form a linear pair because they're congruent. I want you just to think about that statement for a second. Linear pair because they're congruent. That has nothing to do with being a linear pair. If something is a linear pair, it just means that the two things add up to 180. And if you look at those two shapes, the way they drew them, they drew one of the tears like this, and then one of the tears like this. This is clearly an obtuse angle, and this is clearly an acute angle, so they're not congruent. So A is not the correct choice because those two things aren't congruent. The next one says that the paces would overlap each other because they're supplementary. Well, again, that doesn't make sense. Supplementary doesn't mean that they're overlapping each other. That's actually what congruent means. If they're congruent, they would overlap each other. So we can eliminate A and B just based off those facts that it's just not true. C, though, says that these pieces would overlap because they're congruent, which makes sense, but we got to verify if that's true. And then D says the angles would form a linear pair because they're supplementary, which is also true. If two things are supplementary, then they make a linear pair. So we have to go back and think about our parallelogram knowledge. Is X and Y equal to each other, or are they supplementary to each other? And if we think back to that, we actually talked about this yesterday. Remember we said that opposite angles of parallelograms are congruent, but consecutive angles are always supplementary. So opposite are congruent, consecutive are supplementary. So in this case, we've got two consecutive angles, so we know that these must be supplementary, so it's going to be D. Number 40 says, in triangle ABC, angle A is x minus 30, the measure of angle B is 2x minus 80, and the measure of angle C is x minus 70. And it says, what kind of triangle is triangle ABC? Acute scalene, equilateral, obtuse, or right scalene? So first thing I want to do is I want to figure out what to classify it is by its sides, because we know all the sides. We just are kind of missing one crucial piece, which is x. But we have three angles, and we know that all three angles of a triangle always add up to equal 180 degrees. So let's add this up. X, 2x, and x. We add that up and we get 4x. And negative 30, negative 80, negative 70. Well, 70 and 80 add up to 150. Plus 30 gives me negative 180. So then we can solve this equation here. We'll add 180 to this side, add 180 to this side. We get 360 equals 4x. Cancel that out there. And we'll divide by 4, and we get that x is equal to 90. So that helps me a little bit. Now we can go ahead and plug this back in. So if we plug in 90 up here, we get 90 minus 30, so we get 60 for this angle. And if I plug in 90 here, we get 90 times 2 is 180. And 180 minus 80 is 100. And if I plug in 90 here, 90 minus 70 is 20. So if all three sides have come out different, sorry, these are not sides, these are angles, but it still works the same. If all three angles are different, what shape must it be? Well, we know it's not equilateral, so I can eliminate B, which leaves me with just acute, obtuse, or scalene. So again, I look at these angles. One angle's 20, one angle's 100, and one angle's 60. If there's a 90-degree angle, then this would be a right triangle, but none of those are 90, so I can eliminate D. And then we look at obtuse. If one of them's obtuse, then it's an obtuse triangle. And if it's not, then we would just say all three are acute, so it's an acute triangle. But take a look right here. Right here I've got a 100-degree angle, and we know that's obtuse because it's greater than 90. So I know this triangle must be an obtuse scalene triangle, so it's going to be answer choice C. Alright, on to 41. This is actually a very simple question because we've already done it before. It says triangle ABC, M and N are the midpoints of the sides. Which statement best describes the relationship between M and N, so here's M and N, and between A and C, which is this line down here? We already talked about that once. If this is the midpoint and this is the midpoint, then we call this the mid-segment. And I know the mid-segment is always half the length of AC, or that AC is equal to 2 MNs. So taking a look at my answers, the first one right there says MN is equal to half of AC. Is that true? Well, yeah. MN is equal to just half of AC, which is just this little part right here. So it looks like answer choice A would be the one that we want to use. But continuing a little bit further, we also see Oh boy. The AC, this whole line is equal to 2 MNs. So 1 AC is equal to 2 of these. And we know that's true, so B looks like it's the correct answer. And it also says that MN is parallel to AC, which is actually a true statement as well. Any midsegment is always going to be congruent to the base, so C is correct. Uh-oh. Take a look at that last answer. It says D, all of the above. So that is the correct choice, all of the above, because every one of those is a true statement representing MN versus AC. All right, we are at 42. 42 says, what is the value of x? And they gave us this weird looking triangle shape that's got this little arrow off the side of it. So we called this the remote exterior angles theorem, and we said that this angle, the exterior angle, so 4x minus 25, is always equal to the sum of the two remote angles, the two angles that are far away from it. So if I add 3x and 2x minus 5 together, my x's combined, so 3x and 2x gives me 5x. And then we just got negative 5, so let's bring the negative 5 here. And now I've just got this nice little equation we're going to solve. So I'm going to subtract 4x from both sides because they are the smallest. 4x cancels, and I'm left with negative 25 over here equals x minus 5. And then we just add 5 to this side, add 5 to this side. My 5's will cancel with each other. Negative 25 plus 5 is going to give me negative 20. And x is just by itself, so it looks like negative 20 is equal to x. I did something wrong, didn't I? Of course I did. This should be plus 25. Way to go, Mr. Knock. Alright, let's backtrack a little bit, so we'll just add 25 here. And so when I added 5 to this side, I got 30. I'm not going to go back and fix it because that takes too much work. Answer choice is A. Mistakes are good, guys. Learn from them. Alright, 43 is a very straightforward question as well, and it just says, what is the value of x? And they give me this trapezoid, except mine looks like it got squished in the process of being drawn. Yours looks much nicer than mine. But it's got this mark right here and this mark right here. Let me go ahead and pull out my blue. This mark here and this mark here. And it's got these two marks over here and these two marks over here. What that says is that this line right in the middle is the mid-segment of the trapezoid. And we learned the mid-segment theorem says that if we take the top base, base 1, and add it to the bottom base, base 2, and divide by 2, it will give us the mid-segment. So I have the top base, which is 10. I have a bottom base, which we wrote as x, divided by 2, and we know that the mid-segment is in total 13. So now I can work this problem backwards. We're going to multiply this by 2 and this by 2. That causes this fraction to go away, and now I just have 10 plus x on the left side, and on the right side I get 13 times 2, which is 26. And then my last step, we just subtract 10 from both sides, so these 10s go away, and I'm just left with an x equaling, equaling 16, which happens to be answer choice D. Remember this formula. They are not going to give it to you on your test. You have to know it. Write it down somewhere. Look at it before the test. Memorize it. Love it. Be its friend. I don't know. Do something with it. All right, 44. Another easy problem. It says, what is the midpoint of A, negative 2, 5, and B, 7, negative 3? Midpoint formula you do have to know for your test. It's not going to be given. It's just x1 plus x2, though, divided by 2. You take the average of the x's, and then take the average of the y's. So y1 plus y2 divided by 2. So here I've got negative 2 plus 7. So I'm adding these two together, dividing by 2, and then adding these two values together, 5 plus negative 3 divided by 2. So I know that if I do this, here we're going to add these together and we're just going to replace it with a 5. And here I add 5 and negative 3 together, and we'll replace it with a 2. So 5 divided by 2, it looks like in the multiple choice answers they didn't leave it in a fraction, so they changed 2.5, so that's what I'll do. And then 2 divided by 2 is just a 1. So we can look at our answers, 2.5, 1, and that is answer choice B. All right, on to 45. 45 says, if M is the midpoint of Ln, so right here I drew this line segment Ln in blue, and I put M as the midpoint for it. Let me change this color to black so we have something different. So we have M in the middle of Ln. So Lm and Mn are equal to each other because it's a midpoint. And it says, what is the coordinates of N? Well, this is really, really an easy problem. If negative 3, how far is negative 3 from 1? That's our first step. So negative 3, then we'd go negative 2, negative 1, 0, 1. So in order to get from negative 3 to 1, it takes 4 units. So that means the x value, the next x value, is going to be 4 units away. So we'll just add 4 to 1, and we get 5. So our new x value is going to be 5. And then here, 4 to negative 2. How far is it for 4 to negative 2? So in order to get from 4 to negative 2, we had to subtract 1, 2, 3, 4. We had to subtract 6. So we're going to continue this direction, subtract another 6. Negative 2 minus 6 gives me negative 8. So that means that's my y-coordinate. And you could check this using the midpoint formula. 5 and negative 3. If we add those together, we get 2. And 2 divided by 2 is 1. Negative 8 here, and 4. If we add those together, we get negative 4. Negative 4 divided by 2 is negative 2. So that missing coordinate is 5, negative 8. Let me rewrite that because I wrote over it and scribbled on it. So the answer choice is B. All right, 46 says, how many lines of symmetry does the regular polygon have below? Remember, regular means that all sides are equal. So this picture is really sad because it doesn't look very regular. It looks like my top line up here is a little bit bigger than the side lines, but we're just gonna, pretend for now. So a line of symmetry means that if I were to draw a line, or if I was to fold this shape in half somewhere, that would fold directly over on top of each other. For example, if I drew a line through here, well, this would fold directly onto that side, right? Same thing here. If I draw a line through here, it folds over on itself. And if I draw a line through here, it would fold over on itself. So far I've drawn 1, 2, 3 lines, but there's actually 3 more that are a little bit harder to see. 1, 2, 3, 4, right? Because this is this 3-sided shape, and so is this. 1, 2, 3, 2, 2. So there's 5 lines, and here's 6 lines. Little tip for you. It's hard to see, but 6 lines, we'll write that there. Little tip. The lines of symmetry in a regular figure, so lines of symmetry in regular figures is always equal to number of sides. So how many sides does this figure have? 1, 2, 3, 4, 5, 6. So it has 6 lines of symmetry, which is answer choice C. All right, number 47. Yeah, that's a proof, and your wonderful, amazing, spectacular, most awesome teacher, Mr. Nakarado, is going to do that on the board for you. Because to do that in a video would just be really hard, and then I'd be writing stuff on this phone, and it would look like this, and this, and this, this, and this, and you don't want to see that. So watch him, enjoy his presence, enjoy his wonderful lesson. I'll be back in just a minute. Alright, so question 48 says, which value of x makes line 1 parallel to line 2, or L1 parallel to L2? So L1 is going to be this one here, and this one's L2. What's important is if these two lines are parallel, it means ABBA works in them. So again, we see this little drawing, right? Anytime you see these two parallel lines with a line through them, we know we're going to use that ABBA stuff. So let's come up here and we'll do ABBA. ABBA. Oops, I put two B's. There you go. ABBA, ABBA. And we'll put another Dancing Queen ABBA, ABBA down here. So we're going to take a look here. Angle 1. Notice there's a B next to it, so we can put a B here. And angle 2, well, it's got an A next to it, so we put an A here. So what do we know about AB combinations? Well, we know any AB combination is going to be supplementary. Supplementary. So we know these two things must add up together to make 180 degrees. So 4x plus 5x equals 9x. 5 and negative 5, well, those are just going to cancel, leaving with just that 9x. So we'll divide this side by 9, divide this side by 9. These cancel, and we just have x left. And 180 divided by 9 is going to equal 20. And that is answer choice D. Woo woo! Alright, and we are on the second to the last one. It says, determine which of the following, if the following, I don't know what it's trying to say. They spelled wrong. They don't know what they're doing. Which of the following statements is true, though? 1, all squares are rhombi. 2, all parallelograms are rectangles. 3, all kites are quadrilaterals. And 4, all trapezoids are parallelograms. Well, if you have just a general idea of what your Venn diagram looks like that we filled out for the quadrilateral chapter, it's going to help, which is why I drew this square here. Remember, this square was all our quadrilateral universe. And then on the left side, we had a circle with a little circle inside of it. And we knew this circle was trapezoids, and this circle right here was isosceles trapezoids. And then over here, we had a big circle with a little guy attached to it. And this here was parallelograms. And then inside we had two circles overlapping. This one was Princess Rhombus, and this one here was Prince Rectangle. They had their child, remember, they had a baby, and inside this little tiny sliver is a square. And that leaves this last part, which we know was kites, because they were kind of like the oddball. So looking at the first one, it says all squares are rhombi. Look at this. See how this square sliver right here is inside the rhombus circle? That means that every single square must be a rhombus. So we can say 1 is true. 2 says that all parallelograms are rectangles. So here's my parallelogram space out here, right? And here's my rectangle space. Is every parallelogram in this a rectangle? Definitely not, because there's all this extra space out here that doesn't take up rectangles. So statement 2 is not a true statement. Next one says all kites are quadrilaterals. Look at this little kite circle right here. Is it inside the quadrilateral universe? Well, yes, the quadrilateral universe is this whole giant box outside. So every single kite is a four-sided figure. So we know that statement 3 is correct. This actually should be written like this. And statement 4 says all trapezoids are parallelograms. Well, look over here. Trapezoids are not even in the parallelogram world. So we know that trapezoids and parallelograms are very different. The only thing they have in common is that they're four-sided figures. So only 1 and 3 are true, which happens to be statement C. All right, last one for the day, number 50. Javi, here's my shout out to you. If you're not paying attention right now, I'm not happy with you. So pay attention. Except you've missed the entire thing now because we're on the last one, so it's pretty sad. And anyone else who's not paying attention, you should be paying attention. You missed it. All this fun. I'm sad for you. Anyways, number 50 says, which type of transformation does not result in a rigid motion? And if you paid attention yesterday, I told you this answer. There's only one non-rigid motion, and that is a dilation. Dilations are non-rigid, and that happens to be answer choice. Shout it out, everyone. Shout it out. A! Hooray! All right, that's everything for today. Good job. Get ready for your 2-question quiz. I'm sure you're going to do great if you paid attention.